Hi, everybody. I want to make this video to talk about measures of center, which are really just two different things that we're going to use. We're going to use mean and median. And yeah, so let me flip over to a document here. Not that one. That's the Wikipedia page where this came from. So what I have here is a graph of household income in the United States, which is this is actually from 2014. I just got it off of Wikipedia. The fact that it's not the most modern data doesn't really matter for the point I'm going to make. So I want to talk about mean versus median. Mean just means average, and median is the middle number. Now, what we have here is census data about income, and you can see that we've got the number of people making under, or the number of households making under $5,000 a year in 2014 was 4,571,000, 5,000 to 10,000, 4,320,000, etc. Right? So these are all in thousands, and that's what you see here. This is a histogram of that. I do want to talk about two bars in particular. These last two that are very tall. So let me make a point about histograms here. So the one thing I want to mention here is that each of these bars, each of the first bars up until here is $5,000 wide. It goes 0 to 5, 5 to 10, 10 to 15, 15 to 20, etc., all the way up to 200,000. And then after 200,000, it goes 200 to 250 and then 250 and up, right? And so this bar right here is 10 times as wide as the other bars that precede it. And that's why it's so much taller, is because it's capturing a much greater band of incomes, I guess. And so there's just a lot more in that category, and so it ends up being taller. And so when I said this is a histogram, that's not technically true. This is actually a bar graph, because these are all qualitative categories, or excuse me, I'm calling them categorical. These are all categorical categories, which I suppose categories are. I don't have this set up as a histogram because I can't without reformatting the whole table. I don't feel like doing that. It's basically a histogram, though. If you just think of these bars as being $5,000 wide, and then this one's not, right? This one is $50,000 wide, and then this one is more than that. It's 250,000 and up. So this includes Jeff Bezos right here, or I guess at the time the richest person in the United States was Bill Gates. This includes the income that Bill Gates had, as well as, you know, your local doctor. So that's why these bars are so tall, and that's why they seem out of place with the other bars, is because they are. These are indeed actually out of place. And the trend continues like this. It continues to slope downward as it goes to the right. So the reason I bring this all up is I want to talk about mean versus median. And so the first thing I want to note is that this data is what we would call skewed to the right. Which you might think to yourself, well, wait a minute, most of the data is on the left. Why is it called skewed to the right? So it has to do with where the outliers are and where the bulk of the data is. So outliers, which we will talk about in another video, are data values that are unlike the other values in the same data set. So for instance, Bill Gates would be an outlier here, right? His income in 2014 was huge. It wasn't anything like all these other ones. It was far away from them. And we'll talk about how to define what far away from the rest of them means mathematically. It does have a meaning. But for right now, just realize that outliers are things that are data values that are far away from the other data values, or looked at a different way, things that are very unexpected, like unexpected or surprising data values that don't go with the rest of the data very well. So the reason I bring that up is that the outliers are on the right. The big numbers are outliers, whereas all these down here are like most of the data. So what we're thinking of is the bulk of the data is to the left, and so it is being skewed to the right by all those outliers over there. And when I say it is being skewed, what I mean is that the average is being skewed to the right. Because let's just recall what mean and median are. The mean is the average, right? You just add up all the in this case, all the incomes and divide by how many there were, which I think was like 124 million, if I remember the Wikipedia page. We'll go look at it in a minute. And the median is just the middle number. So the median does not care about how big the outliers are. It only cares about where the middle is, right? And so the middle literally means, in this case, 50% of the data is to the left and 50% of the data is to the right. You might say to yourself, well, why do we care about this distinction? And aren't those two things basically the same? Right? The middle and the average sound like they should be pretty much the same. And a lot of the times they are, but in cases like this, they aren't. And so I wanted to talk about which one you might want to use and why. So I want to go look at the Wikipedia page for this just for a second. This is the chart that I stole for my chart back there. And all right, there's tons of data here, data. This is not what I want. I want to talk about mean versus median. So here's mean versus median. They're just explaining what it is here. But here's really what I wanted to see. So the mean, so the average is 72,641. And then the median is 56,000. Those are $16,641 per year apart, which is quite a lot. And the reason they're so far apart is that all of those outliers on the upper end that I was talking about are making the mean bigger, but not the median, right? If we added, let's say, one hypothetical person to the United States who made $1 trillion in 2014, that would affect the average quite a lot, even though there's 100 million people in the United States, trillion's a lot, right? That would bring up the average income quite a bit because that would get added into the numerator, but it wouldn't change the denominator very much at all because we're only adding one more person. So that's a huge outlier, right? Nobody makes anywhere near that much money. I hope everyone's aware of that the very top end incomes are in the billions and $1 trillion is 1,000 times as much as that. So that would bring up the average quite a bit, and it would change the median not at all, because the middle number is still right here, or is still around 56,000, which is where is that? Here-ish, right? So this is where the median is. That means that half of the people in the United States are to the left of this, and then the other half are these to the right. And so what we're trying to do with mean versus median, they're called measures of center, right? So center can mean a variety of things. But the way I prefer to look at it is what's typical. What is a typical, in this case, income? And is it true that a typical income is $72,000, or is it true that a typical income is $56,000? And they're kind of both true. But economists tend to use median for income and for other data that is skewed to the right, and statisticians do. Use the median for income data and other data that is skewed very highly in one direction or the other. It could be left as well, right? You could use the median for left skewed data as well. And the reason you do that is that like I said, there are a few people on the very top end that are changing the average a lot. And so the question is, do you want to consider them when you are talking about a typical income? And I would argue that no, you probably don't, right? If I'm trying to figure out what a typical American income is, I probably don't want to include Bill Gates or Jeff Bezos into that data set because they're not typical. Like they're not typical at all, right? The lowest we can go is $0. And you can see that there are a lot of people down in that range, right? This is 4,000. This is 4 million people here, right? And there's more than that, right? We can see from the data that there's 4.6 million people under $5,000 a year. That's a pretty typical person. I mean, that's a very poor person, but or it's a very poor household, but it's hard to argue that there's, that 4.5 million people don't constitute some variety of typical, right? That's a lot of people. Whereas Jeff Bezos and other people making hundreds of millions of dollars a year are a tiny, tiny, tiny minority. There's very few of them, even in the very rich United States. And so not considering them typical is very reasonable because there's so few and they're so far from the rest of the data. And there's a couple ways you can ignore it. You can cut the people like that out. You can just not include them in your data set and then use the average if you want to. It's called the trimmed mean, where you trim off the outliers and then use the average from there. Or you can just use the median, which ignores them entirely. The median only cares about the middle part. And so when you're trying to define what typical means in a highly skewed data set, that's often what you want to do. So that's the usual argument between mean and median. Mean, you want to, so mean is used very frequently for quantitative data, or for numerical data. I know I'm going to mess that up a bunch of times this semester, sorry. For numerical data, for a reason that we will get to much later when we get to topic 7 and start talking about continuous distributions and learn about the central limit theorem. The mean turns out to be really useful once we have that stuff, and the median is less useful in this context, or in that context, but is often used with highly skewed data where you want to ignore the outliers. So there you go. Let me tell you a couple of some brief how to calculate the mean and median, right? Because you might ask yourself, well, how would I calculate the mean of something like this, where all I have are ranges of data? So I'll show you how you can do that. We'll do it very briefly here in a second. And then I'll talk about how to calculate the median as well. So let me share up a whiteboard. So the mean is the average. And I'm going to use this opportunity to introduce a new symbol to you, or I don't know if it's new to everybody, but it's the summation symbol. This symbol means add up everything, all this. So what I mean by that is you'll see something that looks like this. It's read sum of x. Sum of x. So this means add up all the x's. So if we're getting really precise, we might want to do sum of x sub I so that we have subscripts on everything, but whether you do that doesn't really matter. And then we're going to divide by how many things there are. So this is incomes. And this is number of people, or households, excuse me. And we'll see this over and over again, that the letter N is used for sample size. How many things did you survey? Whereas X is almost always used for data. So what this says is add up all of the data values, and the data being income here, and divide by how many household incomes you surveyed. So add up everything and divide by how many there are, right? That's the average. You guys know that. And then so this is how you calculate the mean. It turns out apparently this is about $72,641, at least according to Wikipedia, who I'm just going to trust in this case. The median is the middle. And if you have trouble remembering that, think about a highway median. Highway median is the thing that runs down the middle of the highway. And it's obviously, it means the same thing, right? It's the middle. The way you calculate to calculate the median, you put all your data in order, and then the position of the median is n plus 1 over 2, where n means the same thing here as it did in the last screen, which is the number of things in your data set. So let me show you why this works. So I'm going to have a data set of 1, 2, 3, 4, 5. 1, 2, 3, 4. Actually, let me. I'm sorry. I'm gonna use different numbers. I'm going to use 1, 5, 9, 13, and 17. Okay. So that's my data set. Obviously, this is just some numbers here. The way I can find the position of the median is, so in this case, n equals 5, because I have 5 things. So n plus 1 over 2 is 6 over 2, which is 3. So what that means is, once I have my data in order, and to do the median, you do have to have it in order, I'm going to look in the third position. So my data is currently in order. I'm going to look in the third position and find that I have 9. And that's the median, right? That's the middle number, exactly what you'd expect. A more interesting question here is, what happens when you have something like this? Where there actually isn't a middle number. Well, n is 6. So n plus 1 over 2 is 7 over 2, which is 3.5. So I'm going to look in the 3.5th position, which is to say between 3 and 4. Right? So here's 3, here's 4. Between them is right here. And what we do is we take the average of 9 and 13 to find the median. So the average of 9 and 13 is 11. So the median of my second data set here is 11, even though 11 isn't actually in the data set, because there is no middle number. There's no single middle number. And that happens whenever you have an even number of things, right? Or an even number of data points. So my median here is 11, here it's 9. And the way you calculate the position of the median is n plus 1 over 2, and that position corresponds with the data being in order, and then you look at that position in the list. So that's how you find the median. I assume you already knew how to find the mean, but I will actually show you when we get some bigger data sets where we want to find the means ourselves. I'll show you how to do that in your calculator. And in fact, I might as well show you how to do it on Sheets right now. There's a command for it. It's very convenient. Let's go look at Sheets. This is my spreadsheet, but I can't do this one. Let's do this. What is this one? This one. Here we go. So this is some data that I was making earlier for a homework assignment. Okay. So what I've got here is, I think I have what, 500 or something like that. Yeah, I have 500 data values in here. And so, yeah, it's that. So what I'm going to do is to find the mean and median, I'm just going to use the commands average and median. So if I want to find the median, so median. Okay, so to find the median, what I'm going to do is I'm going to go into a cell and start with equals, which if I start with equals, that tells the computer or tells Sheets that the thing I'm putting after that is a formula. So I can put in a bunch of commands, and there's a huge list of them over here. Like this is like all the commands you could ever want. There's so many of them that they don't even just list them all out, right? They do if you look at all, but they have them broken down by ways you would use them, right? And so I happen to know what these are called, but if you want to look through these, you can. Averages is mean, obviously. And then min and max are the minimum and maximum values, which are going to be relevant to us in a little bit. But I'm just going to use median, since that's what I'm looking for. So equals median. And here's one thing I really like about Sheets. You start typing it in, and it gives you, or you start typing in the command, and it will give you all of the commands that start like that. So I want median here. And then once you click on the command that you want, it'll tell you what to put in order to calculate that. So it says, here's what it looks like, value 1, and then a list of values is what that means. And so you can say something like A2 to A100, You can also do this. You can also like select all the ones that you want, and I just want everything in column A. Boop. So I'm just going to say A to A, close parentheses, and it finds them for me, right? So the median here is 10.22. And if I go look at the list in order, what we would find is that there is no 10.22 in the list. This is the average of two things around 10.22 because there's 500 here, which is an even number. Mean, same thing. I can use average. It's average, right? And it's give me the same thing like list of values. So I'm just going to say column A, close parentheses. And sorry, I have this generating randomly. The median doesn't actually change in a data set. I apologize. All of these are randomly generated, and every time I hit enter, it makes new ones and changes the mean and median. So sorry about that. But you can see that the median now 9.6 and the mean is 10.6, right? So you can just use those commands in Sheets if you want to find the mean or median. And when we do a little bit more with this, I will show you how to do it on the calculator too. Actually, I suppose I could just show you how to do that right now. Let me go ahead and pause the video because that's going to take me a little while to set up. All right, so I've got the calculator all warmed up after a solid couple of minutes of loading. Let's go look at that. So here's the calculator. Here's my my TI-8384 emulator. And so what I'm going to do here is introduce you to a couple of things. First thing I'm going to introduce you to is the concept of putting data into your calculator, which you do that via the stat button, which is a good place for that, I suppose. So I'm going to hit the stat button, and it's going to bring me to this menu. And the option we want is the first one, edit. So I'm going to edit. Oh, by the way, I hit enter there. You can see that here, but that's the button I hit. Sorry, I tend to do it on the keyboard rather than using the mouse to press everything. So these are called L1 through L6. They are your lists. The L stands for list, I believe. And this is where you put data into your calculator. This is basically a spreadsheet right here. So I'm just going to put in some numbers here. -3. Hello? Computer 3. Okay. All right, good. 17, 24, 0, 18, 6, -19, and 35. There we go. Okay, so there is some random numbers that I'm just that I'm jamming into the calculator. I'm going to find the mean and the median of those numbers. And I'll also show you how to sort them. So what I'm going to do, once I put them in here, you don't have to save or anything. I'm just going to quit out of here. And by the way to get back to your blank screen in a TI calculator is to use the quit button, not clear or delete, which gets rid of things. So the quit button is the second function of mode here. So the blue buttons on top, in case you're not familiar with this type of calculator, there are, I don't know if you can see this or not. Can I blow this up? I don't know if that's helping you to see this, maybe. I hope. There are blue commands as well. There's the button, the main thing on the button here is stat, and then there's a blue one called list. And you get to this by hitting this button called second, this blue button called second, which accesses all the blue commands. You might notice that there are some green ones up here as well that's accessed by the alpha button. So you hit alpha and then this up caret, and it'll give you an H, which we don't need an H right now, so I'm not going to do that. What I am going to do is hit quit, which is the second function of mode. So second mode brings me back to my blank screen here. And then what I'm going to do is I'm going to go back to the stat menu. So stat. And the way I'm going to find my mean and my median is something called one variable stats. We're going to use a good chunk of these at some point during the semester. The one we'll use most often by a huge margin is this one, number 1. One variable stats. And the reason I'm going to use that is because it finds all of the helpful things that we want, including the mean and the median. And it's going to ask you what list to use. And we of course put everything in list 1. So that's the one I want. But in case you wanted to change the list, the way you would change it to like L2 or L6 or whatever is, if you'll notice, L1, 2, 3, 4, 5, and 6 are the second functions of the numbers 1, 2, 3, 4, 5, and 6. So if I want L2, I would do second and then the 2 key, and it will give me L2. Now I do want L1, so I'm going to go back to L1. L1. And whoop, sorry, I forgot it. Delete it there. There we go. I'm going to do L1. Now, frequency list, we will talk about this more at some point, but not right now. And then I'm just going to hit calculate. So just leave frequency list blank. And then I'm just going to hit calculate. And when I do that, my screen will fill up with a bunch of information. Now, the mean is this, 9.75. That was the mean of those numbers that I put in. And then the median is down here a little further. It's under med. So median is 11.5. We're going to talk about what all of these other things mean. Well, not all of them. But in another video, we're going to hit S, and this is a sigma. This thing looks like a O with a tail. Sigma. This N is the same N I was talking about before. It's sample size. This tells you how many things are in your data set. And then min and max don't take much explaining. Median is the middle number. And then these Q1 and Q3, we will talk about when we get to measures of dispersion or spread. But yeah, rest assured those will be important as well. So my median was 11.5. My mean, which they just call X with a bar over it, which you say X bar, by the way. This symbol is called X bar, is 9.75. And then if you remember this symbol that I showed you just a second ago, sum of X, this is the sum of all the things in your data set, or in our data set, apparently was 78. These other, like this is used for some calculations. This is if you squared all the things in the data set and add them up, you get 2,820. That will never be relevant for us. Yeah, so my average was 9.75 and my median was 11.5. So that's how you can do this on the calculator. Let's go back to my whiteboard. Yeah, so that's the mean and the median. And by the way, there are commands for this in SPSS if you want to use SPSS, which don't use SPSS. But if you really want to, I'll show them to you. And there are commands for it in Excel as well. And I believe the Excel commands are exactly the same as the Sheets commands. I think they're in fact, median and average are what the commands are in Excel. So that's mean versus median. Let me briefly summarize. If your data is highly skewed, you would probably want to use the median because the median will automatically, not automatically, but it ignores the outliers. It only cares about what the middle is or what the middle value is. And in a distribution that is similar to the one we were just looking at, which was, where's that one? Yeah, except this was on sheet 3. Yeah, when we were looking at this distribution has a bunch of outliers in it because there are some very extreme incomes. And when you want to ignore those in calculating your typical value, you probably want the median. If you want to include all the extreme values, then you would want to use the mean. And the mean is the one that ends up being used most often. For our class, we won't actually use the median all that much. We'll use the mean a lot. And I'll talk more about that when we get to the central limit theorem and why we would want to do that. But yeah, that's mean versus median, and those are your two typical measures of center. There is a third one that I almost don't even want to mention because we're barely going to use it at all, called the mode, which is the most common value. And if your data is numerical, we're not going to use the mode because there's not going to be a most common income, right? Like almost nobody makes $56,000 a year, even if that's the most typical income. Everybody's going to make like $56,125.38 or whatever, right? And the most typical income is not a thing we care about, or the most common income is not a thing we care about. What we want is for a typical value, we want the mean or the mean or median to sort of guide us to where the bulk of the data is. The reason you might want to use mode is that it's the only one of these three that works with qualitative data or categorical data, right? You can say which category has the most data in it. That's really the only way to define typical with categorical data is via the mode. So mode just means the category with the most in it. That's it. Yeah, I'm not going to say anything more about that. I believe we will use the mode never. I think maybe never is it's going to be relevant to us, but that is the other kind of central value or most typical value that you could use. Okay, and with that, I think I want to end the video. So this turned out to be quite a lot longer than I was intending. Sorry about that. Yeah, I think I will go ahead and end the video here, and I will see you guys in the next one.